Okay, so this example is all to do with correlation and regression. One of the things what we'll look at is a regression line. It's not something you need to know how to calculate, though actually calculator's got a function that will do that for you anyway. But in the exam, you might be given an equation for a regression line and be asked to use it in a number of different ways. So in the example here, we've got some information from a large data set, so about daily mean wind speed and the maximum gust. That's been recorded from Camborne. That data is shown in the tables here, so you've got that information, but we don't really use that, to be honest. Scatter graphs plotted. I've just done like a quick sketch of what that would look like, so this isn't drawn accurately. I mean, you'll very quickly be able to see that I've not got as many crosses as I should have, but essentially it's going to look something a bit like that. And the first question, it says, describe the correlation between daily mean wind speed and daily maximum gust. Well, obviously it's positive correlation, but you're not going to get marks for just saying positive correlation in a A-level exam, only something a bit more in depth. So what we can say is that, yes, there is positive correlation. So this suggests that there is a linear association between daily mean wind speed and daily maximum gust. Linear association means that the crosses are basically forming a straight line, linear, like linear graphs. And then we could also say something along the lines of, as the daily mean wind speed increases, so does the maximum gust. Okay, so the next part of this is saying that the equation to regression line of G on W for these 15 days is G equals 7.23 plus 1.8 W. Essentially, the regression line is the line of best fit. So in the past, you've just been drawing it by sight. Now we actually have an equation for it, and that's the equation that we have here in this particular example. And we're asked to give an interpretation of the value of the gradient in this regression line. So the gradient is the 1.82, because that's really like a y equals mx plus c thing. We've got 1.82 w, so the 1.82 is a gradient. So what we can interpret from this is that as the daily mean gust increases by 1 knot, on average, the daily maximum gust will increase by 1.82, because that's what gradient really tells you. It tells you how much y increases when x increases by 1. And so in this example, we're talking about as w increases by 1, the gust will increase by 1.82. So an increase of 1 knot in mean wind speed means the maximum gust would increase by 1.82. And then question C, justify the use of a linear regression line in this instance. Well, that's really to do with, if we drew a line onto our scatter graph, would it be going through most of the crosses? And it pretty much does, doesn't it? We've got something that's quite a strong correlation there. And so that means that a regression line would be suitable. So we might say something along the lines of, a regression line would be suitable to use in this example because the crosses are close to a straight line and we have fairly strong positive correlation. Equally, if it was negative correlation, it was strong, then that would be fine too. It's not to do with whether it's positive and negative or not, it's just to do with whether or not the correlation is strong, be it positive or negative.